and welcome to another webcast in the Iconics Transform Your Business webcast series. Today's webcast is Advances in Voice Machine Interfaces for any industrial or building project. Before we get started, my name is Amanda Gordon. I'm the Senior Marketing Programs Manager here at Iconics, and I'd like to go over a few housekeeping rules with you today for the webcast. Right now, you are in a listen-only mode. That means if you have any questions throughout the webcast, you'll want to type them into the questions section of your GoToWebinar panel. You can also email us offline and we can answer questions at webcast@iconics.com. Now let me introduce you to our presenters for today's webcast. Today we have Luc Gagne, who's a solution sales engineer. His email is here as well, and he is in our Foxborough, Massachusetts headquarters office. We also have Chris Ellsbury, who's the Chief Software Architect at Iconics, again in our Foxborough, Massachusetts headquarters. And with that, I'm going to turn things over first to Luc to get us started.
Excellent. Thank you, Amanda. So just before we transition away from this slide here, I just wanted to give a little more background on myself. I'm a member of the solutions sales team here at Iconics. Our main responsibility is working with new and existing customers to find what Iconics solutions meet their application needs. That being said, I encourage you to reach out to me directly, and you can see my email there. It's just Luke, Luke, @iconics.com, with any questions about the presentation or any general software questions. Like I said, reach out to me directly. I welcome all responses. And that being said, Chris, you want to do a little introduction on yourself?
Yeah, sure. So I'm Chris Ellsbury. So I'm in the engineering department at Iconics. So in that department, we're the ones who write the code that makes the products run. So yeah, I've been with Iconics for about 25 years now. So I've seen the software evolve through quite a bit over the years.
Awesome. And you want to go to the next slide, Chris? All right, just to start our presentation, we're going to do a little background on Iconics. And perfect, thank you, Chris. So before Chris starts the bulk presentation on the voice machine interface, I just want to thank everyone again for joining us. The VMI, or voice machine interface, as you guys already probably heard me say multiple times, is a new exciting feature of the software, and we appreciate everyone taking time to listen to this webcast and the opportunity to tell you about it. To start with a brief note about Iconics, we are headquartered in Foxborough, Massachusetts. Our HMI SCADA applications span the globe and are installed in over 100 countries. We have over 375,000 installations worldwide. These installations span a wide range of industries. Our biggest groups or market sectors are building automation / smart building applications, discrete process manufacturing, and public infrastructure such as rail transit, airports, etc. In addition to all of that, we are a 6-time Microsoft Partner of the Year. We are very proud of those accolades. And Chris, if you can jump to the next slide. And this is just a further breakdown of industries I just mentioned. I guess I'll just, before the presentation starts, just a blanket statement. Our main goal at Iconics is to deliver HMI SCADA systems to individuals like yourselves that are working in these fields that we see on the screen every day. And we appreciate that, and we hope make those operations as smooth as possible. With that said, I'm going to turn it over to Chris for the presentation.
Thank you. So just a brief agenda of what we're going to cover today. I'm going to start by just kind of talking about what is voice machine interface, or what are we talking about, just sort of in general. Then get a little more specific about voice machine interface in an industrial setting. Then specifically how Iconics is leveraging voice machine interface in its products. And then we'll switch back to Luke for a live demonstration of voice machine interface. So for an introduction to voice machine interface, what we're talking about here is basically using speech to obtain information, basically, or invoking actions using some computational device. So some common examples of that, things like your smartphone, smart speakers, basically devices that are running these voice assistant applications, like things like Alexa and Google Assistant and Cortana and Siri. Yeah, in addition to these, like smartphones and smart speakers, a voice machine interface could also be a PC or laptop with a microphone. It doesn't have to be a dedicated device. With voice machine interface, it doesn't necessarily require a visual aspect, but visuals can sort of augment the experience. So for example, what I'm showing on screen here is two different devices. One is an Alexa device with a screen, one is an Alexa device without a screen. So obviously when you don't have a screen, you're limited to voice input only and audio feedback only. And of course with a screen, you can get visual feedback as well. So an example, you might ask, what is the weather? And the device with no screen could just sort of respond verbally with, it's sunny and the temperature is 65 degrees Fahrenheit. The device with the screen could have the same audio response, but you could also, for example, show a temperature graph for the day or a weather map for your region. So basically you can sort of augment the response with visuals. It's sort of been a long road to how voice machine interfaces has gotten to where it is today. If we look back in time, one of the earliest examples is in 1952, where Bell Labs demonstrated a device that could understand basically just spoken digits, and that's it. And a decade later, IBM demonstrated a device that could understand 16 English words. And it kind of advanced from there in the 70s. 1970s, it got up to being able to understand around 1,000 words. In the 1980s, there were sort of advances by using probability to try to estimate, whether unknown sounds were actually words. By 1990, you had the first consumer speech recognition product, Dragon Dictate. In 1996, Bell South introduced the VAL system. There's basically a dial-in voice portal. So anytime you're using, one of those automated voice menus on the telephone, that's kind of where that originated from. By 2001, voice machine interface, voice recognition had achieved an 80% accuracy. And in 2011, Apple introduced Siri, and that sort of kicked off the sort of modern, current voice machine interface that we're accustomed to nowadays. It really exploded in popularity after that. And today we're at an error rate of about 5% in voice recognition. And so sort of to put that in context, a 95% accuracy rate is basically a level that's acceptable to consumers. It's actually on par with the error rate of a professional human transcriber. This is one of the reasons why we have this sort of recent rise in popularity, is that the accuracy is now sort of good enough. But sort of how we got to that accuracy and convenience of voice machine interface, things like advances in natural language processing. So for example, specifically named entity and intent recognition. And what that means is, if you've got a statement like, you say, I'd like to book an airline ticket from Boston to Seattle. So the objective of that statement is to reserve a flight from one location to another. So in that case, the intent is reserve a ticket. And also in that statement, you've got entities, which are basically objects that could be physical or abstract, such as people or places or organizations or products that have some sort of a proper name. So in this case, the named entities would be the departure city Boston and the destination city Seattle. So that's what those concepts mean. The rise in popularity of voice recognition has also been concurrent with the rise of cloud computing. So what this makes speech recognition possible on lower powered internet devices, because you're basically offloading the workload to the cloud processing to be able to do that. So that's why we're able to have these devices like smart speakers that don't necessarily have a lot of processing power, but can still do this voice recognition commanding. The rise in popularity of voice recognition is also concurrent with the rise of smartphone ubiquity, right? Everyone has a smartphone. So consumers are already carrying around these devices that are voice-oriented and internet connected, which is sort of exactly what we need for these voice recognition applications. And basically just voice interaction is easy for consumers to understand, right? You don't need to learn a specific graphical user interface. It's just the way people naturally communicate. So it's an easy way to understand how to ask for information or issue commands. So yeah, the common uses of voice recognition in consumer space is obviously things like digital assistants, where you're basically getting information through spoken natural language, and that can obviously be more convenient than having to type in equivalent search text, especially if you don't have a keyboard and you're trying to do it on a touchscreen. Just saying what you want can be simpler. Also useful when you're initiating actions where you need to be hands-free. So obviously something like driving, while you're driving, you could initiate a call or ask for directions from your smartphone or your navigation system in your car. It's also useful for accessibility, where you've got potentially people with physical disabilities that can't use a keyboard and a mouse, or people with repetitive stress injuries that you may have to limit their use of a keyboard or mouse, or people with cognitive or learning disabilities that they can use their voice but can't necessarily do the typing on a keyboard or mouse. Also, we see it commonly used in home automation, so being able to do things like control your home's thermostat or the lights or entertainment devices via voice. So sort of switching from the consumer space and looking at what can we do with voice machine interface in an industrial situation. So issuing voice commands for monitoring the status of systems and processes, controlling equipment and devices. So basically, just some brief examples using natural language. You could start and stop equipment, change temperatures or set points, things like viewing work orders, or using voice to sort of make sense of large amounts of data, basically requesting key performance indicators. And I mentioned hands-free operation earlier, but hands-free operation and eyes-free operation is also useful in industrial settings, because situations in industrial settings can require hands-free and eyes-free. So, take for example an operator that needs to wear bulky or dirty gloves, and so they would otherwise potentially need to remove those gloves to use a touch screen or a keyboard. Whereas with a voice machine interface, they wouldn't have to go through that extra step of removing the gloves. An operator might need to need both hands for performing a task, and they maybe need to be doing that task while simultaneously requesting information or instructions related to the task. And an operator may also need to be visually focused on the task and can't necessarily be looking at a screen, so they may need to be getting voice feedback information as well. So, for example, the worker in this picture, I mean, this is a person who really needs their hands and their eyes free. This person wouldn't be able to conveniently pull out a tablet or a smartphone to get information. They need to stay focused, so they could have a voice capable device, on their person. In this case, the operator is wearing a RealWear headset, and so they could be issuing commands and getting voice feedback. Hands-free can also be important or desirable in basically in today's environment where we're dealing with the COVID-19 virus, and basically not having to touch shared equipment, for example, an industrial touchscreen. That can help reduce chances of spreading infection. So being able to actually do this hands-free issue voice commands is also helpful in that respect. So if we look at voice machine interface across different roles or different kinds of users, just some examples, a plant or operations managers, they might ask something like, what is the OE for line 1 and how does it compare to last shift? And you could get a response back from the device. The OE for line 1 is 78.3%, which is up 2% from yesterday. Another role might be in facility maintenance. User could ask, what is the current voltage of this chiller compressor? And they can get back a response. The current voltage of this chiller compressor is 200 volts at 50 hertz. And this can also apply to executives, where they may be sort of asking bigger picture kind of questions. What is our total oil production year to date, and how does it compare to last year? And they can get back the response, you've produced 5,640,000 barrels of oil year to date. That's up 4% from last year. So the kinds of questions that get asked and the kinds of responses you can get, the context can vary depending on the kind of user that's using the product. So yeah, what I'd like to switch to now is actually discuss how Iconix is actually specifically leveraging voice machine interface features in its products. So there's sort of two kinds of voice machine interface we can talk about in the Iconix products. One is at the front end client, one's in the back end server. And on the front end client, we're talking about you're interacting with some sort of an HMI display and you want to issue voice commands. So in that case, the voice is captured and interpreted locally on the current computer. That could be a HoloLens device, could be a RealWear device, could just be a microphone connected to a PC. So that voice recognition is processed locally on the current PC, and the action or the response is initiated on that same device. Now, the response might be to write a value to a remote server, but sort of that the whole recognition and initiation of the action all happens on that front end device. When we're talking about backend voice machine interface, that's when we're starting to talk about these smart assistants that I was talking about earlier, like, for example, Alexa and Cortana, where the voice is captured, for example, by an Alexa device, but that voice then goes to a cloud service in the cloud that does that voice recognition, and then initiates an action by basically calling into an Iconix Genesis 64 backend server to actually execute the action. So I'm gonna focus mostly on this idea of the backend voice commanding. The front end stuff is something we've had for quite a long time, and it's really the backend voice commanding that I want to get into a little more closely. We do have some other upcoming webcasts that will cover things like the RealWear device and the HoloLens device. So they'll probably be touching on that sort of front end voice stuff a little more. So I'll focus on the back end stuff. And so that's going to be things like Alexa, Cortana, and Google Assistant. So to kind of explain a little bit more how this works, so as I mentioned, the speech recognition is actually happening in the cloud here. So this is a solution that it does require internet connectivity. And it does require some additional configuration that happens in the cloud. And I think maybe Luke will be touching on that a little bit when he talks about configuration. So there's basically, like I said, there's just sort of this server-to-server communication going on. It's not, the voice recognition is not happening at the client. And because we're dealing with a cloud service here and communicating to another backend, it does require some enhanced security, which is done through this OAuth 2 protocol. What OAuth 2 is basically, it's a widely adopted security protocol, and it makes it easier to log into applications so that you don't need to sort of remember a password for every site or application that you go to. So if you've ever used something like on the internet, like log in via Facebook or log in via Google, that's using this OAuth 2. So in this case, Iconix is using it to basically allow the cloud voice services like Alexa and Cortana to use Iconix security to authorize the users that are using the voice machine interface features. And so part of what makes this all possible is Iconix has basically a bridge between these cloud web services that are providing the voice recognition, a bridge to the Iconix platform services. And this uses basically different plugins for the different voice services. And again, as I mentioned, it's using the OAuth 2 for authorization. So that's very important to keep the system secure. So when we're talking about voice machine interfaces, we have to sort of discuss this concept called skills. And skills basically define how an application is going to respond to these voice commands. So there's a couple different kinds of skills. There's custom skills and there's smart home skills. Custom skills are really about being able to define any sort of phrase that you or action that you want. So it's a more flexible approach, but it does sort of have the disadvantage that you have to identify the skill name as part of what you're asking. I'll get into that a little bit more shortly. The smart home skills are a little more restricted in the kinds of things that you can ask, and that sort of the skills, obviously, because the name implies, apply to sort of home automation type skills. So it's sort of this fixed set of commands that you can issue that relate to the kinds of things that you can control in a home or building situation. But the advantage is that because these are sort of known pre-built phrases, you don't need to know what the skill name is when you're asking the question, and multiple languages are sort of supported out of the box, and the same commands are used across all the smart devices from all different manufacturers. So for example, with the Alexa smart home skills, this could be used for building automation scenarios. Basically, the phrases are defined by the device manufacturers and Amazon and Google, but it's, again, the same phrases no matter what kinds of devices you're using, whether it's actual smart home devices or whether it's through the Iconix system. And as mentioned, multiple language being supported out of the box makes it very easy to configure for multiple regions. So the kinds of things you can do with a smart home skills are things like turning lights on and off, or adjusting their brightness, locking and unlocking doors or windows, interacting with things like security cameras, entertainment devices. With HVAC, you can adjust temperatures, control fan speeds, etc., things like that. And so smart home skill integration with Iconix, through AssetWorks, we can sort of define, basically organize the devices that you're going to be controlling, like, for example, light controllers. So we can organize it in, in terms of, what building you're in, what floor you're in, what room you're in, and then what devices are in that room, and what you can control about those devices, whether it's, for example, with lights, it might be the brightness, the on-off state. Some lights you can even adjust the color. And we can use RecipeWorks to basically group multiple actions to take effect on multiple devices. So, for example, we could have this concept of a day mode and a night mode, and that might turn on and off multiple lights across an entire floor or an entire building. Custom skills, on the other hand, are a more generic solution, and they can really apply to all use cases. So there is some additional configuration on this, in that you have to sort of define what are the phrases that are going to be recognized and what should those phrases do. So we have to define what are the intents in this case. And part of that is the intents have to be configured in the cloud service provided by, for example, Amazon for Alexa, or Google, or Cortana. But then the handling of that intent is configured in the iconic system in Workbench. So, I mean, as mentioned, it does mean that the user needs to say the skill name. So you need to sort of identify, for example, ask Iconics to do something, right? Because we need, the cloud needs to know where to sort of direct that voice recognition to take the action to respond to what you're asking your device. And so you do have to sort of provide also the intents in all the languages that you want to support. So let's kind of take a look at how does this all work? How does this all fit together? So we start, a person says to their device, just as an example, Alexa, ask the robot to get me a beer. So in this case, the robot, that's the skill name in this case. We can name the skill whatever we want. So that, as this is an example of a custom skill, we have to include that skill name in the request. So that speech is going to go out to the Amazon cloud, and that's going to get converted into text, and that text is going to get passed on to the Amazon skill that we configure. Now, the first thing that needs to do is we need to check authorization. Are we actually authorized to be making this request? So basically, through that OAuth 2 protocol that I mentioned, it's going to go back to the Iconic server, and it's going to verify that that user is allowed to make this request. So we get back an OK. And so now we can pass this request on to in this case, the Alexa plugin in the Iconics web platform services. So that Alexa plugin is then going to go basically through frameworks communications to the Iconics backend framework server. And so we may have configured that intent to basically say, when someone asks, ask the robot to give me a beer, then the intent is that will actually write, for example, the value 1 to an asset property beer type within the beer robot asset. So we'll get back a response from AssetWorks. Okay, yeah, that write was successful. So that's going to go back to the plugin, and the plugin is going to say, okay, this is the response I want to send back to the Alexa device. So it may say, okay, getting beer, please wait. So that goes back through the cloud, back through the skill in the Amazon cloud, and then it's going to come back to the device as a synthesized voice response. And it's going to say, okay, getting beer, please wait. And so visually, this is what it's going to end up looking like. The robot is going to get you a beer. So with that, I'm going to turn it over to Luke to describe the configuration in a little more detail.
Awesome. Great job, Chris, as always. So I got probably, I think it's 3 slides, and then I'm going to go into the actual product demo of how we can use this VMI in the Genesis software. But just to, the 3 slides I'm going to show are going to be more of a summary and just a reinforcement of concepts that Chris has already covered. He did a great job explaining a lot of that. These slides are just going to act as a very macroscopic view of these different concepts. So the first question, and like I said, Chris already talked a lot about what is a skill. And the analogy I would use is that a skill to your VUI, voice user interface device. So whether that's the Amazon device, I don't want to say its name because it's sitting right next to me and it's going to start talking, but Google Home or Microsoft Cortana, the skill to those devices is the same as an app on your phone. So you can go onto Amazon or Google Play Store and download these skills. There's different tiers of combinations of paid and unpaid skills, and they perform different actions. Okay, so there's thousands of skills available on these portals for perform common tasks. Examples could be setting an alarm, playing your favorite song from Spotify, or playing a voice interactive game of Jeopardy. So possibilities are endless. Okay. All of these tasks are powered by the provider's API service. So that can be Amazon providing a API endpoint, or it can be a custom endpoint, which in the case of Iconics, the skill is actually going to be using, and this is actually the last slide Chris just showed, but the ICO web API point manager. So we're going to be using the Iconics software as the quote unquote brain of our Alexa skills. And we'll see how this all shakes out in the product in a couple of minutes when I get to my demonstration. But Chris, you can go to the next slide now. So we have these skills, and now the next step, once we define them, is this invocation, which is just the words we're going to use to invoke that specific action. Okay. So the invocation has 2 parts. The first is the wake word, which is just the name of the device and how we want to greet it. So you can say, hey, Cortana, hey, okay, Google Home. And then the second part of that word or phrase is to invoke the skill. So that's when you would say, Cortana, play a song from Spotify. The play a song from Spotify would be the skill name or the invocation name. And for our demo, I've created an iconic skill, which you'll see me interact with my device here in a couple seconds. And Chris, you can move on to the next slide. Okay, and then, so we have our skill, we have our invocation name, what we're going to say to trigger this skill. Now the next step is going to be creating a intent. And you can picture intent or an intent or a group of intents as a web of interconnected, what they call utterances. So you can just think of it as all possible ways the user may phrase a request. So an example would be asking the device, what is the current number of alarms, versus asking how many alarms are there. The user is asking the same thing, but wording it differently. So you would be creating intents for both to allow the backend server to map the request to the same action. And these actions, we define these actions by using a matching intent in the Iconics workbench. So like I said before, the Iconics software is going to be the brain of the operation. Amazon development platform, Google development platform, or the Microsoft one are going to be the customer-facing voice recognition side of things, but the Iconics software is going to tell those platforms what answers to say. And the last point here is that we can parameterize our intents using this feature called slots. So for example, if we want to refer to alarms both as alarms and alerts in our requests to our device, we want to be able to do that because I might call them alarms, Chris might call them alerts. We want to be able to still get information about our alarms in our system, even though that we're actually saying different things, okay? With that being said, Chris, you can go to the next slide, and I'm going to take control and actually get into the product demo itself. For this video, we created a simple demonstration showing the core concepts of the voice-machine interface with my Alexa device and Iconics software. What we're looking at right now is an overview of a chain manufacturing plant. The center of the screen is a floor layout with the statuses of my different pieces of equipment. We have our asset navigator on the left side of our screen, an alarm viewer running along the bottom of the screen. We then have navigation buttons in the top banner of the display. We can use the VMI for two main purposes. The first purpose is top-level KPIs for a manager or supervisor. We can relay alarm information or any other metrics we are tracking in our Genesis system. For example, I will invoke my Iconics skill to retrieve the number of current alarms. Alexa, use the Iconics skill.
Hello and welcome to the Iconics skill. How can I help?
What is the current number of alarms?
There are currently 9 active alarms in the facility.
Notice how I invoked my skill using the phrase Iconics skill. We can also use the slots or parameters in our request. So instead of asking for alarms, I will ask for alerts. Alexa, use the Iconics skill.
Hello and welcome to the Iconics skill. How can I help?
What is the current number of alerts?
There are currently 10 active alerts in the facility.
Notice how I was able to invoke the skill using alerts and how Alexa's response used the slot. We can also use our VMI to limit contact with high-touch areas. This is good for a couple reasons. The first being is if the operator is busy completing a task and does not have a free hand. Another reason is to limit the spread of germs between operators. For example, I can navigate my display using a voice command. Alexa, use the Iconics skill.
Hello and welcome to the Iconics skill. How can I help?
Show me the 50-line overview.
Okay, here are the line details.
Once we're in the line overview, we can ask the device for order information. For example, Alexa, use the Iconics skill.
Hello and welcome to the Iconics skill. How can I help?
What is the status of the order?
The order number is B4403. 58 more strands of our S100 are required to fulfill the order.
The operator could also use the VMI to interact issue commands to the physical equipment. We create a mock display of the manufacturing line. To emphasize, this next graphic is not something you necessarily want in a facility. I am using it to explain the concept of hands-free interaction with the equipment. Alexa, use the Iconics skill.
Hello and welcome to the Iconics skill. How can I help?
Show me an operator view.
Sure, here is an example of an operator view.
On the display, we have a conveyor producing strands of chain. We have 2 hoppers dispensing some plates and bushings, a hydraulic press and a vision system at the end. We can slow the pace of the assembly using a voice command. For example, Alexa, use the Iconics skill.
Hello and welcome to the Iconics skill. How can I help?
Slow the line down.
Line speed reduced to 20%.
And if the operator notices a defective part, we can stop the line completely to perform manual inspection. Alexa, use the Iconics skill.
Hello and welcome to the Iconics skill. How can I help?
Stop the line.
Line stopped.
Once the inspection is complete, we can resume production with another voice command. Alexa, Use the Iconics skill.
Hello and welcome to the Iconics skill. How can I help?
The inspection is complete.
The line is now running.
And that is all for the demonstration. To summarize, we create custom skills using our development platforms, whether that is Alexa, Google Home, or Cortana. We connect these skills to our Genesis 64 endpoint to execute commands and retrieve information. With that being said, that is the conclusion of my presentation. Amanda, if you want to take back over here.
Thank you very much for that informative presentation. Let me switch to my screen here and show you my conclusion slides. Okay, and now I'd like to talk to you about the Iconics Worldwide Customer Summit Transform 360. We recently rescheduled this in-person event to May 4th through 7th, 2021 at Foxwoods Resort and Casino in Connecticut. If you already signed up for the event and you'd signed up for the previous dates, we've just moved your registration already to the new dates, so no action needed on your part. If you haven't already signed up, I encourage you to do so. This event is going to be bigger and better in 2021. We have a number of exciting guest speakers lined up as well as compelling demos to show you. If you register by April 19th, you can do so at iconics.com/transform360. We have a number of promotions that we put up on our social media pages from time to time, including complimentary registration promo codes. So I encourage you to follow us on social so you can see those and sign up. I really hope to see you all there at this live in-person event. I'd also like to share with you a number of on-demand webcast recordings that we have available at iconics.com/webcast. If you've enjoyed today's webcast, you can see the other topics that we have covered this year. And not only do we have these North American webcasts, but we also have a number of international versions as well. And while I'm answering the questions today, I'm going to leave this slide up for questions and comments so that you can see our presenters, Luke and Chris. Their contact info is here, as well as our solution sales team. Here we have a number of people that you can contact with. You can contact in North America as well as international if you have follow-up questions with like a personal demo, etc. So with that, I'm going to start taking some questions. So let's see what's come in here. All right, the first question that I have here is for Luke. Can this voice machine interface be used to read write from databases?
Yeah, that is a great question. So the underlying data for the VMI is going to be routed through our AssetWorks module. So that being said, AssetWorks sits on top of our universal connectivity. Sorry for me stumbling on my words, but sits on top of our universal connectivity. And as I'm sure you well know, database support is included in that, most common being SQL, but any other database connection can be connected to AssetWorks and then connected to this VMI interface. And we have the ability, we can write text or just a numerical value. We have some freedom in that.
Okay, thank you, Luke. Next question, Chris, you can take this question. Can VMI integrate with AlarmWorks 64 server to convert generated alarms in voice?
I mean, well, you saw in the demonstration that we can certainly ask AlarmWorks, information about the alarms. In terms of just sort of getting sort of current or new alarms coming in as generated voice. I mean, I guess that's really more of a voice synthesis rather than a voice recognition type scenario. So it doesn't really sort of follow the the idea of issuing a command or asking for questions. So in that sense, it's more just you would need to use the voice synthesis option of basically the read back accessibility features of the device or the operating system. in that sort of scenario. So I'm not sure exactly how it would be configured, but I think it should be possible.
Thanks, Chris. Next question, Luke, can you take this one? It is, who will provide endpoint URL and authentication details to configure Alexa or Siri in Genesis 64 Web API configuration?
All right, so there's two pieces in that question I want to touch on. I'll actually have Chris touch on the latter, which is the Siri implementation. But first, in regarding the endpoints, so when you configure your skills and intents on your development platform, they will provide you the URIs to integrate to the voice user interface software. Okay, so Amazon will provide URIs to connect to the Genesis 64 software. You will have to use, I believe it's OIDC, some type of authentication party, but that's all going to be provided by the web service provider. And then in terms of plugging your endpoints back into the Amazon provider or whatever software you're using, or not software, but whatever VMI you're using, when Iconics is installed, we make the necessary changes to your IIS settings. So you might want to check with the RT department before doing that. And then in that installation, we also create virtual directories. And those act as the endpoints for these various web services. So hopefully that wasn't too long-winded and that made sense. Please, I encourage you to follow up if I didn't do a good job explaining that. And Chris, can you just touch a little bit on the Siri support part of that?
Yeah, sure. So yeah, as far as Siri goes for the voice machine interface, we do not currently support Siri. That's primarily sort of an architectural issue, is that the way the Siri voice stuff works is very different from Alexa and Google and Cortana, and it's sort of more of a closed system that really only interoperates in the Apple ecosystem. So there was sort of more limited use cases. It didn't really fit into the architecture, but we're not, though we don't have it and it's not currently planned, we're open to the idea of doing it. It's really just going to depend on customer demand.
Thank you, Chris.
All right, thanks, Chris and Luke. Next question is for Chris. I think this is the best one for you. How effective is VMI on a noisy plant floor?
That's a good question, and it really depends on the device. If you're just using for example, a microphone on a PC or maybe some of these consumer devices like an Alexa, noisy environment might be problematic, but there are devices that are intended for industrial use. For example, the RealWear headset that are designed to deal with these noisy environments and can sort of filter out the noise and get the voice more clearly. So specifically if you're using like a headset, you're going to get sort of better voice recognition than if you're using a device that's using sort of a multi-directional microphone. So it can be effective. It really just depends on the device that you're using.
Okay, thanks, Chris. Next question, Luke, can you take this one? It's, can I make the skill response shorter?
Yeah, so I was actually going to make a witty joke about that in my presentation because as you guys saw, every time I referred to the device, it said, welcome to the iconic skill, how may I help you, blah, blah, blah. Like I said, I was chuckling to myself as I was saying. I understand that that can be a little annoying every time, but the short answer is yes, you can configure that and change it to be as long as short as you want. And also the development platforms for these services are very powerful in the sense of we can establish how skills transition from one to another. So say, for example, you ask, okay, how many alarms? The Alexa will give you the response, and then you can have Alexa ask you a question back. Oops, sorry, my device is hearing me. But you can ask the device, for a response back, and they'll give you another question, and you can continue that dialogue back and forth without having to invoke that skill every single time you want to perform an action or get some piece of information.
Okay, thank you. We are approaching the next hour, so I'm just going to take a couple more questions, have a lot on this one. The next one, Chris, I'll have you take this one. Can I use with Cortana on local intranet?
Well, in terms of the voice recognition, I believe, it's possible to use sort of a local Cortana voice recognition sort of on device if you're using our native mobile HMI application. But if you're using basically the cloud service, it's in the cloud. It needs to be an internet capable device because that Cortana service is coming from the internet.
Okay, thank you. And Luke, question for you. Do I have to be a coder to integrate my Alexa or other voice-enabled device with my Iconic software?
No, which is a great thing because someone who's not as tech savvy like myself was able to program this Alexa. So the development team at Iconics has done a great job. They have created, for you guys who are familiar with Iconic software, in Workbench, our back-end configuration tool, we have created a provider for the Web API service. And Chris actually mentioned this JSON file that gets sent back and forth to the cloud, perform these tasks. You type in, with using standard Iconics expression editors and tools to generate, and it automatically generates and deploys your configuration file. So as far as the Iconic side, if you're familiar with Iconic software, that's all you need on that. And then Amazon and these other providers have done a great job providing, people like me and you, the adequate, tools and resources to build our own skills and so forth.
Okay, thank you. And with the time that we have left, I'm going to take the last question that I know the answer to. And we had a few questions that we didn't get to that we will follow up with you offline. We try to keep these to an hour. My question that came in is this webcast being recorded? And yes, all of our webcasts, including the international ones, are being recorded. At the bottom of our webcast page, the iconics.com/webcast, if you scroll down to the bottom of those, you will see all of the recordings from our past webcasts. So you can watch any of those, and I recommend you do so. And with that, I'm going to wrap things up for today. I'd like to thank everyone for joining us. Thank you, Chris. Thank you, Luke. And definitely register for more webcasts today at iconics.com/webcast.